Alright guys, so let's go ahead and get started with this chapter 15 video. I'm on page 453 in your workbook. I'm gonna blow this up a little bit. Let's take a look at number 1. You have an order for 500 milliliters of dextran to be infused over 24 hours, right? So 500 has to go over a whole day basically. How many milliliters per hour should the IV pump be programmed for? So for this one, right, all we do here is 500, right? And you just divide it by that 24, which will give you 20.83. I'm gonna round to my nearest tenth, make it 20.8 because the pumps usually don't go to the hundredths place. So our pump will be programmed for 20.8 milliliters per hour. If you want to double check if that's correct, all you have to do is then just multiply 20.8 back into 24, right? Because it has to run for 24 hours. And you'll get 499.2, so essentially 500. So that's how you can check if you're doing your math right. Okay. Number 2, there's an order for acyclovir 400 milligrams every 8 hours. The acyclovir is already dissolved in 100 milliliters of normal saline, and that has to be infused over 1 hour. So how many milliliters per hour should your pump be programmed for? Okay. So a couple of things. In this case, all of this right here is unnecessary information. Okay. Because your acyclovir, your medication, is already dissolved in a liquid, right? So all we have to work with is these are 100 milliliters and that it has to be infused over 1 hour, right? And so that's your answer, 100 milliliters, 1 hour. So you're gonna set your pump to be 100. Okay. All right. Number 3, you have an order for a medication that's every 12 hours, already dissolved in 100 milliliters of IV fluid. It has to be infused over 30 minutes. Our tubing drop factor is 15. How many drops per minute should be given? Okay. So kind of like in number 2, this right here, we don't really care about it because the medication is already dissolved in a bag, right? So all we need is this part. We need to know over what time frame they want us to infuse it, and then we have our drop factor. Okay. Anytime you're solving for how many drops per minute you need to give, you need to have a drop factor. Okay. So let's set this up. We have X, GTT, that means drops per minute. Okay. We have our 15 GTT per milliliter. Okay. We know that we need to infuse 100 milliliters over 30 minutes. That's our order. Okay. So my milliliters will cancel out, leaving me with my drops per minute, right? So I like to go across, so 15 times 100, and then I divide by 30. That's what I'm gonna do. My answer is 50. All right, number 4, licensed prescriber orders 3,000 milliliters of TPN to be infused from 1900 to 0700. How many milliliters per hour should the IV pump be programmed? So the key in this question is understanding your military time. Okay, 1900 is 7 p.m. So this infusion is 7 p.m. to 7 a.m. It's an overnight one, right? which is 12 hours. Okay, so then now we know that we have to infuse 3,000 milliliters over 12 hours, right? So how many milliliters per hour is that going to be? So we'll just divide 3,000 by 12. And our answer is 250 mils per hour. Okay. Number 5. Patient has an order for famotidine 20 milligrams in 100 mils of D5W. Famotidine has to be infused over 30 minutes. Our tubing drop factor is 10. How many drops per minute should be given? All right. So again, this right here, unnecessary information. We don't care how often we have to do it either. All we need is our fluid that we have, how fast we need to infuse it, and our drop factor. So XGTT over minute, right? Drops per minute. I start with my tubing factor, drop factor over milliliter, right? It's 100 milliliters that I have to infuse over 30 minutes. Okay, so again, I like to just go across, so I'm going to do 10 times 100, and then I divide by 30. And I get 33.333, right? It keeps going. So we can't have, half of a drop or a third of a drop. So in this case, in real life, you would just round down to 33, whole number. Okay. All right, number 6. Malnourished patient has an order for 500 mils to be infused over 6 hours. How many milliliters per hour? Okay, so, right, we don't really care about this, right? All we need is what our volume is, right? How much we have to infuse and how quickly we have to do it. So 500 divided by 6. And I get 83.333, right? It keeps going. So we're just gonna call it 83.3 because our pumps only ever recognize the 10th place. Okay. Moving right along. Number 7, you have an order to infuse penicillin G. It's already mixed in 100 mils of D5W. Here's your tubing drop factor, right? Needs to be infused over 60 minutes. How many drops per minute should be given? So we're gonna do as we have previously, GTT over a minute. I start with my drop factor, which is 10. I have 100 mils to infuse, and I have to do it in 60 minutes. Okay, so again, I like to do a cross first, 10 times 100, and then I'm going to divide by 60. And I get 16.666, right? It keeps going. So again, can't have 2/3 of a drop, so I'm just going to round up to 17. All right, number 8. A patient with hypokalemia has orders for potassium, already looks like infused in 250 of water, right? Facility states it has to be infused at this rate, so 20 milliequivalents per hour. And then how many milliliters per hour should the IV pump be programmed for? So let's see. We're looking for X ml per hour, right? we have 250 milliliters, right? And we have to use this 60 milliequivalents because the rate that they're giving us is in milliequivalents per hour, not in milliliters per hour. That's why. So then we take this rate that we're given, 20 milliequivalents, right, per hour, right? That way these units cancel, leaving me with milliliters per hour. So I'm gonna go across again, 250 times 20, and then I divide by 60. And I get 83.333, right? So we'll just call it 83.3. Okay. All right, number 9. Post-op patient has ceftriaxone 1 gram ordered every 8 hours. It's already dissolved in 50 milliliters of D5W, right? Has to be infused over 30 minutes. Here's your drop factor. How many drops per minute do you need to give, right? So drops per minute, GTT per min. Always start with my drop factor, so 60. Right? I got 50 milliliters that I have to give over 30 minutes. So we'll do 60 times 50 and then divide by 30. And I get 100. Okay. I'll keep going here. So it looks like we have a stat dose of Zosyn to give over 15 minutes. How many milliliters per hour should the nurse program? So again, this is all unnecessary information. You just need your volume, 100 mils. Needs to go over 15 minutes, right? But your question is how many milliliters per hour. So we'll do XML per hour. We have 100 milliliters. We know it has to go over 15 minutes, right? And then we know that 60 minutes is 1 hour, right? So we're gonna do 100 times 60, divide by 15. And we get 400. Okay. All right, moving on. Number 11, patient with sepsis has an order for cefazolin 1 gram and 50 over 15 minutes. Your drop factor is 60. Again, unnecessary information. We just need our volume, how fast it needs to go, and our drop factor. So X GTT minute. Always start with our drop factor first. Volume, and then how fast we're gonna make it. Yeah. So 60 times 50, and then divide by 15. And I get 200. Next question. So patient with MRSA has Cipro ordered. Looks like it's 400 and 200 mils. Pharmacy recommends that it needs to infuse at a rate of 200 milligrams per hour. So how many milliliters per hour should the IV pump be programmed for? Okay. So we know we're looking for milliliters per hour, right? we know that our order is 200 mils, right? And that there's 400 milligrams of medication inside it, right? We know that from this right here. And it also tells us the same thing on the label. Okay. Pharmacy told us that it has to go in at 200 milligrams per hour. Okay. So now that we can cross out our milligrams, leaves us with our milliliters per hour. So we're good to go. We do 200 times 200. And then we're going to divide all of that into 400. So my answer is 100 mils per hour. Okay. Moving right along, let's see. Patient has an order for 1,000 milliliters to be infused over 1 hour. Your tubing drop factor is 10. How many drops per minute? So XGTT over a minute. Start with your drop factor first. And then we have 1,000 milliliters, right? 60 minutes, right? 1 hour is 60 minutes. So 10 times 1,000. And then we divide by 60. So I got 166.666, right? It keeps going, so we'll just call it 166.7. Oh wait, we're doing drops. So we have to call it 167. There we go. Okay. Next one. Looks like we have an order for 500 milliliters of something to be infused over 4 hours. How many milliliters per hour, right? So again, unnecessary information. All you need is your volume and how fast it's going. So 500, we're going to divide it by 4. It's 125. And that's it. Moving right along, number 15. Patient has an order for Toradol. It's diluted in 25 milliliters. Your tubing drop factor is 15. How many drops per minute? Okay, so again, a lot of unnecessary information here, right? All we need is how fast it needs to go, the fact that it's already diluted, and our drop factor. So GTT, minute. Starting with my drop factor first. Okay. So it's 15 times 25 and then divide by 15. So this is just going to give you 25 as your answer. Number 16, you have an order for hydromorphone at 0.5 milligrams per hour. Your bag has 20 milligrams in 100 mils. How many milliliters per hour should the IV pump be programmed for? Okay, so we have X ml per hour, right? We're gonna start with our bag, right? So we know that we have an 100 milliliter bag, and that entire bag is equal to 20 milligrams of our medication, right? And then we have our order, which is 0.5 milligrams over an hour, right? So our milligrams will cancel out, leaving us with the milliliters per hour. So 100 times 0.5 and then divided by 20. So 2.5 is the answer I got. Okay. Moving right along. Patient with peptic ulcer disease has an order for famotidine. Looks like it's already diluted in 25 mils of an IV liquid. Here's my drop factor, and I know it has to go over 15 minutes. DTT over minute. Always start with my drop factor first. $25 mils is my volume, and it has to go over 15 minutes. So we have 20 times 25, and then we divide by 15. So I get 33.333, right? But can't have a third of a drop, so we're just gonna call it 33. Okay. Number 18, patient with alcoholism has an order for magnesium sulfate, 2 grams in 100 mils. Pharmacy recommends that the magnesium be infused at a rate of 1 gram per hour. How many milliliters per hour should we program the pump for? So X ml per hour, right? I need my volume, 100 mils. I know there's 2 grams of mag sulfate in there, right? Here's my order, 1 gram, 1 hour, right? So my grams will cancel out. So this becomes 100 divided by 2, which is 50. That's your answer. Number 19. Patient has an order for 1 unit of red blood cells to be infused, right? So 1 unit is equal to 250 mils, right? Facility policy states that it has to go in over 4 hours. Your tubing drop factor is 20. How many drops per minute should be given? So we have GTT per minute. Always start with my drop factor, right? 250 mils, right? I'm told it has to be 4 hours, right? And I know 1 hour is 60 minutes, right? So my milliliters will cancel out, my hours cancel out, leaving me with my drops per minute. So 20 times 250, and then down here, 4 times 60. Okay. So 20 times 250 is 5,000. 4 times 60 is 240. 5,000 divided by 240. I get 20.83. But this is drops, right? So I'm just gonna round it to 21. Okay. Okay. All right, moving on. Number 20, patient has an order for something that is 1,000 milligrams in 100 milliliters, normal saline, over 50 minutes. How many mils per hour? Okay. So all we really need here is we know that our volume is 100 and that it's going to go over 15 minutes, right? But the question is, what is it for milliliters per hour? So ml per hour, we have 100 milliliters, 15 minutes. And then we know that 60 minutes is an hour, right? So my minutes will cancel, leaving me with milliliters per hour. 100 times 60 and then divide by 15. So I got 400. Okay. All right, another potassium question. So how many milliliters per hour? I'm just gonna start right there. XML hour. Okay. Looks like I have 200 milliliters and my potassium is diluted in it, so 200. And I have 40 milliequivalents in it. Okay. My rate needs to be 10 per hour. So 200 times 10 divided by 40. And I get 50 as my answer. Okay. Another TPN, again, key here is knowing your military time, right? So 2200 is 10 p.m. So this is 10 p.m. to 8 a.m. overnight. Okay. So that's what? 10 hours total? Right. So then your volume right here, 1350, is going to infuse over 10 hours. So how many milliliters per hour? We're just going to divide 1350 by 10 and get 135. Okay. Number 23. Let's see. I'm just going to go straight XML per hour. That's what my question is. I have 50 mils of something, right? Looks like I have 2 grams and then 1 gram over 1 hour. Right, so this essentially becomes 50 divided by 2, which is 25. Okay. Next one. Again, ml per hour, that's my question. How many milliliters per hour? Right. I have 200 mils. That's supposed to infuse over 1 hour, so that's your answer, 200. Okay. Drop factor again, so we know that we're going to start with GTT per minute. Right? Tubing drop factor is GTT per milliliter. I have 100 milliliters that I need to infuse in 30 minutes. So 20 times 100 and divide by 30. I get 66.666, right? It keeps going, so we're just gonna call it 67 because you can't have 2/3 of a drop. Okay. XML per hour, that's my question. Looks like I have 50 mils of something that needs to be given over 30 minutes. And I know there's 60 minutes in 1 hour. So I'm gonna do 50 times 60 and divide by 30. And I get 100. Okay. Drops per minute. My drop factor is 20. I have 250 mils. Or sorry, 200. 200 milliliters. That's gonna go over 1 hour, right? Or you can just say that 1 hour is 60 minutes to save yourself time on conversions, right? So like, we don't need this, all of this, right? 20 times 200, divide by 60. Again, I get 66.666, so we'll just call it 67. Okay. XML per hour. I have 500. 8 hours, right? 500 divided by 8, 62.5. Okay. Again, XML per hour, right? I have 250 milliliters. I have 200 milligrams in those 250 milliliters. And then my order said to do 5 milligrams per hour. So 250 times 5 and divide by 200. I get 6.25, and we'll just round it to 6.3. Okay. And then number 30, that'll be my last question for this video, so it's not too long. Let's finish strong with a drop factor, GTT per minute. My drop factor is 60. And then I have to infuse 50 milliliters of something over 30 minutes. So we'll do 60 times 50, divide by 30. And I get 100. Okay. That is it for this video. Thank you for watching.